θ, it is the same term which has been squared, isn't it? So it is 1 plus cos θ squared. Or you just cross multiply, sin θ times sin θ is sin. Prove the trigonometric identity sin θ over 1 plus cos θ, then plus 1 plus cos θ over sin θ to be equals to 2 over sin θ. So the first thing you need to do is to investigate the identity before you prove it. Are you seeing that? You investigate the identity. So if you investigate this identity, you can see on the left hand side of the equation is where we are starting from, and we get up with what is on the right hand side of the equation, isn't it? We are starting from sin θ plus 1 over cos θ, then plus 1 over cos θ over sin θ. Then we are supposed to end up with a single term. So for us to end up with a single term, meaning we must first make this a single term, isn't it? We look for the L, for the LCM. So the LCM is the product of the two terms in the numerator, isn't it? So the LCM is sin θ times 1 plus cos θ. Then you start 1 plus cos θ goes here how many times? It goes sin θ times. So sin θ times sin θ is sin squared θ. Then we have plus sin θ goes here 1 plus cos θ times 1 plus cos θ. It is the same term which has been squared, isn't it? So it is 1 plus cos θ squared. Or you just cross multiply, sin θ times sin θ is sin θ squared, 1 plus cos θ times 1 plus cos θ is 1 plus cos θ squared, isn't it? Then denominators squared. Are we together? So the next step is to open that bracket in the numerator. So we have sin squared θ plus. So what is 1 plus cos θ squared? That is a quadratic identity, isn't it? It is a quadratic identity, a plus b squared. So a plus b squared is a squared plus 2ab plus b squared. A quadratic identity. So we've been told we have 1 plus cos θ squared, meaning a is 1 and b is cos θ. So where there is a you put 1, where there is b you put cos θ, isn't it? So what do you end up with? 1 plus 2 cos θ plus cos squared θ. You've expanded that, isn't it? Are we together? So we have 1 plus 2 cos θ plus cos squared θ, then all over sin θ, then 1 plus cos θ. So look at the numerator, you simplify the numerator. And remember, many cases when you are proving a trigonometric identity, you will either get that Pythagorean identity or a double angle. Will always arise from any trigonometric identity. Are we together? The first Pythagorean identity will always feature. If it is not there, then a double angle, a case of a double angle will feature anytime you are proving a trigonometric identity. You will see it is either a case of a double angle featuring, or it is a case of a Pythagorean identity. And you know the first Pythagorean identity is that one you are seeing there, sin squared θ plus cos squared θ is 1. So it means sin squared θ plus cos squared θ in the numerator is 1. So we have 1 plus 1, then plus 2 cos θ over sin θ into 1 plus cos θ. So you simplify. 1 plus 1 is 2, isn't it? Are we together? Yes. So we have 2 plus 2 cos θ in the numerator, then the numerator sin θ into 1 plus cos θ. Then you see the numerator 2 is a common factor, and 2 is even what is required there, isn't it? So if you factorize 2 outside, you remain with the 2 into 1 plus cos θ. Then in the numerator we have sin θ into 1 plus cos θ. Then you can cancel out the common factor. Then you remain with the 2 over sin θ. So that is the first thing you need to know. Anytime you are proving a trigonometric identity, you will always see, if it is not a Pythagorean identity, then you will see a double angle. You will see a case of a double angle, meaning if you have a case like sin 2θ to be 2 sin θ cos θ, meaning if you end up with something like this, isn't it?